everyone. Good afternoon, good evening. Today we are here for yet an interesting topic, differential equations. Yes, you may be wondering what this is, but uh, when we try to take a few steps back, remember something like dy dx. We did this and we said we were differentiating. Then we had this symbol introduced, and we said you were integrating. And we made sure we got to understand that this is the reverse of the other. So today, from the knowledge you got from differentiation and integration, we get to combine it and put it to use in what we are going to be calling differential equations. Let me take you back to this. We have seen equations. For example, this one x plus by equals to c. Yes, we call this a linear equation if you recall. Then you also had ax squared plus bx squared plus c equals to 0. We call this a quadratic equation. Now, all equations that will follow or will have a dy dx in them, these equations today we are going to be calling them differential equations. And you may be asking, yes, differential equations, we are seeing the dy dx, but how do we make sense of the whole thing? Well, the first thing you need to understand, dy dx, it's to power 1, yes, and that's first order. And we have this squared y dx squared, the same thing as dy dx, but now this is to the power 2, second order. If we have the 4dy dx power 4, this is the same thing as dy dx to power 4. So whenever we are differentiating and we are using dy dx, all our equations follow orders. Yes, and when I say orders, we take the dy dx part by the one with the highest power. For example, in an equation like this, we have dy dx, the 4y dx power 4. Why are we not considering this as the order of the equation? Well, it's not the highest. We still have this one, so we are taking this d power 4 1. So the order of the equation will be the 4 dy dx power 4. So I would like for us to go straight to work. We are going to have one of our first examples here, and we are going to be solving the differential equations. I have dy dx minus 5 equals to 0. Well, now we have been given a differential equation. Why? It has an element of dy dx, then it has an integer here, an integer there. So what are we going to do? First things first, we separate. We have a dy dx and we have a constant number here. So I'll first separate the two. This crosses this side, come this. Now, second step, I'm going to try to split this. Yes? And how am I going to do this? I'm taking the dx this side, so I mean with dy equal to 5 dx. Yes? Then I'm going to introduce the integral sign on both sides. Now, when I integrate this, yes, what's the integral of dy? You got it right, it's y. To equal to that is the integral of 5, now to become 5x, because we are dealing with respect to x. But we remember whenever we are integrating, we always get a constant. So we shall have our constant here plus c. Yes? So that's it. When we are solving differential equations, and we shall hop into this as advanced later on in the topic, we first make sure we split up, we organize our work like we did here, then split it up before introducing integral signs. So that was example 1. Let me get another example here. If you have dy dx, this is b plus 3 equals to 0. Now this is the same thing. We are going to do exactly the same thing. We isolate these 3 so that we only remain with y dx, but this side shall have it y dx equal to negative 3. So I bring the dx, the other side remain with dy equal to negative 3 dx. Introduce the integral on both sides. Here, what is the integral? Integrate dy, we will get y. Negative 3 with respect to x, it will be 3 negative 3x plus constant of integration c. There you have it. Yes, let's move on to the next now let's try out something else. Yes, you may pause the video, note down this and that before we continue. Yes, so having said that and that, we may as well continue. Now, yes, we have seen, yes, we are solving differential equations, but not every time they are going to give us the simplest one for us to solve. So, before we continue, we have to understand that these differential equations fall into categories. I would as well like to classify them according to the different types. Well, we can have a separable. 2. We can have the exact opposite, yes, inseparable. 3. I would have the exact, yes, we shall see all that. Now, under this differential equation, we are going to be dealing with basically these 3 types here. But under this topic, we are going to see questions like solve, form an equation. Then lastly, we will see real life examples of how we apply this knowledge. For example, as we shall see, maybe they will give you an example of water cooling at a certain temperature from a certain temperature, and you are being asked to use differential equations in some way to get an answer at some point. We shall arrive there, but note the equations we are going to be dealing with. First thing shall be solving. Second shall be forming. Yes, forming what? The equations. 3, we shall be using this. We shall be applying the knowledge in real life. Situation. So we know that under the differential equations, we are going to be dealing with separable and separable exact. However, solving, forming, and applying whatever you are doing in real life situations. Now, I want us to first focus, yes, on forming the equations. Note differential equations is always the climax of differentiation and integration. So every number we will be doing, there will always be differentiation and integration. So to get this topic, you must have got your differentiation and integration properly. Now I'm going to have something under forming the equations. Example 1, I can have y equals to x plus a over x. So the question here is form a differential equation. Yes, so that's our question. Now, if I'm going to solve this, one thing I have to put in mind, I have to get rid of the y. Yes, and if I'm differentiating, most likely I will differentiate with respect to x. So when I'm handling this, I would like to work around that until I get my final solution. So first things first, I look at making A a subject of the formula. How will I do that? Yes, that's basic mathematics. We shall come here, y equals to LCM will be x. Then we can have x divided by 1 x times the x here. Can have it x squared, then plus a. Yes, multiply xy will equal to x squared plus a. Make a the subject, a will equal to xy minus x squared. I'm going to make this my equation 1. Yes? Now you can proceed with differentiating the two.